Good morning, dear students. Welcome to our class, and we are doing Analytical Chemistry, Chapter 4. Now, in our previous class, we learned about the action of sodium hydroxide solution on certain metallic salt solutions, and by observing the color of the precipitate formed, we figure out which metallic salt is given as the sample, and we also compared the solubility of the precipitate formed by different metallic cation. Now today we are going to see the same effect and understand the similar effect of another alkali, which is a weak alkali, that is ammonium hydroxide solution, on similar metallic salt solutions. And we are going to study metallic salts of calcium, iron, copper, zinc, and lead. So we are going to see the effect of weak alkali, that is ammonium hydroxide solution, on these metallic salts. Now we have to understand that ammonium hydroxide is a weak base. Therefore, it produces less number of hydroxide ions. Now this lesser number of hydroxide ion produced by ammonium chloride causes some changes in the way these different metallic salts form precipitates and their further action on excess amount of ammonium hydroxide solution. Okay, like sodium hydroxide, ammonium hydroxide also has to be added dropwise to the solution of metallic salt. This is done because if we add the alkali rapidly to the metallic salt, then sometimes we might miss the precipitate that gets formed during the reaction. So to get the precipitate properly, we have to carry this reaction in a very meticulous method. That is, we have to do this reaction drop by drop. That means we have to add the alkali drop by drop to the metallic solution so that we can achieve the desired precipitate, okay, of the metallic salt. Therefore, now we are going to see the effect of ammonium hydroxide on these certain metallic salt solution. Let's go to first calcium. Now calcium salt, for example calcium nitrate, calcium sulfate, these calcium salts, they do not form any precipitate with ammonium hydroxide. This is because of less number of hydroxide ions produced by ammonium hydroxide on ionization. Therefore, what we have to understand over here, ammonium hydroxide does not produce any precipitate of calcium salts. Even in excess amount of ammonium hydroxide, calcium salt do not form any precipitate. Now, if you compare with sodium hydroxide, these calcium salts were forming white precipitate of calcium hydroxide, which was sparingly soluble in excess amount of sodium hydroxide. But in case of ammonium hydroxide, this calcium salt do not form any precipitate. So this particular test can be one method by which we can separate sodium hydroxide from ammonium hydroxide. Okay, let's move on to another metallic salt, iron ferrous salt and ferric salt. Like the action of sodium hydroxide, ammonium hydroxide also forms precipitate of both iron salt, that is ferrous salt also, as well as ferric salt, and they have very similar reaction. So ammonium hydroxide will produce ferrous hydroxide. This is a double displacement, so they will exchange the ion, so along with ammonium sulfate, which is a salt. Now this ferrous or iron 2 hydroxide is dirty green like it was in with sodium hydroxide, because the hydroxide form in both cases are same, therefore their color will be also same. With further addition of ammonium hydroxide, that is in excess case also, here also both the hydroxides or precipitates are insoluble. Okay, in sodium hydroxide also both the precipitates were insoluble. Let's go to third metallic salt, that is copper salt. Now copper salt, let's take copper sulfate, which is blue in color due to the presence of copper cation, which is blue. Now this reacts with ammonium hydroxide and undergoes similar type of reaction as with sodium hydroxide, and therefore it will form copper 2 hydroxide, which is a pale blue precipitate. Now this pale blue precipitate, on further treatment with excess amount of ammonium hydroxide, it forms a soluble substance. That means it undergoes, or it is soluble in excess amount of ammonium hydroxide. And this copper 2 hydroxide, when treated with excess amount of ammonium hydroxide, it dissolves to produce a copper ammonium complex salt, which is deep blue in color. Therefore, what we have to note over here, copper sulfate forms pale blue precipitate with ammonium hydroxide, but this pale blue precipitate, in addition with excess of ammonium hydroxide, it will produce, or in fact it will dissolve to form copper ammonium sulfate salt, which is deep blue in color. Therefore the color of the precipitate changes from pale blue to deep blue. Now this is a little different reaction compared to the reaction of sodium hydroxide. Let's go back to sodium hydroxide. Now copper salt, on treatment with sodium hydroxide alkali, they also produced pale blue precipitate initially, but when excess amount of sodium hydroxide is added to this precipitate, which is formed by the action of sodium hydroxide, this precipitate remained insoluble. That means the pale blue color remained intact. There was no change in the precipitate formed. That means this precipitate was insoluble in excess amount of sodium hydroxide. But over here, with excess amount of ammonium hydroxide, this pale blue precipitate of copper 2 hydroxide dissolves, okay, and forms another complex of copper ammonium sulfate, which is pale or deep blue in color, and the precipitate, the original precipitate, which is pale blue precipitate, is soluble. Okay, so this reaction can also be used to differentiate sodium hydroxide alkali and ammonium, between sodium hydroxide alkali and ammonium hydroxide alkali. So I have told you two reactions by which we can distinguish sodium hydroxide and ammonium hydroxide from each other. Let's go to another reaction, action of ammonium hydroxide on zinc salt. Now zinc sulfate, let's take zinc sulfate. Zinc sulfate, which is a colorless salt, and its solution will be also colorless. When treated with ammonium hydroxide solution, it forms white gelatinous precipitate, same as sodium hydroxide. Okay, sodium hydroxide also forms white gelatinous precipitate of zinc hydroxide, and this white gelatinous precipitate of zinc hydroxide, like on treatment with excess amount of ammonium hydroxide dissolves. Okay, that means the zinc hydroxide white gelatinous precipitate formed by sodium hydroxide also dissolves in excess amount of sodium hydroxide, and the zinc hydroxide white gelatinous precipitate formed by ammonium hydroxide also dissolves in excess amount of ammonium hydroxide. So here in both the cases of alkalis, these hydroxide, metallic hydroxide form gets dissolved. That means both the hydroxide are soluble in these two alkalis. Let's go to the last salt, which is lead salt. Now lead salt, over here we have lead nitrate, which is a colorless because lead is a colorless cation. Now this lead nitrate also forms white PPT of lead 2 hydroxide, like sodium hydroxide was producing. But the difference over here is, with excess amount of ammonium hydroxide, this PPT, white chalky PPT, does not dissolve. It remains insoluble. But in case of sodium hydroxide base, this white PPT of lead hydroxide was soluble in excess amount of sodium hydroxide. So this particular reaction can also be used to distinguish between sodium hydroxide and ammonium hydroxide. Am I clear, boys? So these are some of the qualitative analysis that we can do to figure out or to find out the cations present in any given salt with the help of alkalis. And we have learned the use of two alkalis. They are strong alkali sodium hydroxide and weak alkali ammonium hydroxide. We also learned that these reactions can also be used to distinguish between sodium hydroxide and ammonium hydroxide, or in other way we can also say these two reagents, sodium hydroxide and ammonium hydroxide, can be used to differentiate between different types of metallic salts. For example, if we use say suppose sodium hydroxide, okay, to distinguish between calcium salt and lead salt. So with the characteristic of precipitate formed and their behavior with excess amount of alkali added, we can distinguish between two given metallic salts. So with the help of this analysis, we can find out three things. One, the cation present in the given sample. Number two, the difference between two or three types of salts with the help of reagents. And number three, the differences between sodium hydroxide and ammonium hydroxide. I want you to go in detail in your book. Okay, please practice writing chemical reactions. The more you practice, the more easier it will be to know the answer, because you don't have to mug up this answer. It is just that you have to know the basics. What type of reaction are these? If you know the type of reaction, the type of product, to write the type of product will be very, very easy for you. I'll be giving some assignments, written assignments. Please complete your assignments, but before doing your assignments, watch this video again and again. If you are not clear, refer to your book. You can also refer to your online other different ways, YouTube, your Google it out. Okay, and still if you have any problem, you can mail me or WhatsApp me, then you answer your questions. Stay safe, do all things well.